After this lesson, you will be able to solve any equation with radical term. So this the first question is asking us to state the restriction, what is allowed, what is not allowed for x inside this radical. So the only restriction that we have here is that this number should be positive, because we are not allowed to have negative numbers inside the roots. So 2x minus 1 should be positive, greater or equal than 0. Okay, so we can add plus 1 here. 2x minus 1 plus 1. We will do the same thing, 0 plus 1 here. So 2x is greater or equal than 1. So we can divide by 2 here. We will do the same thing for the other side. So x is greater or equal than a half. So the solution for this one, all numbers, okay, starting from a half. So from a half up above, including half, all these are solution. For the second example, which is asking us to solve for x, x, first thing you need to do, 5 plus square root of 2x minus 1 is equal to 12, which means that we need to put minus 5 here. 5 minus plus square root of 2x minus 1, you will put minus 5 here and minus 5 to other side. So square root of 2x minus 1 is equal to 12 minus 5, which is 7. So now to take out the square root, you need to put a power of 2 for both sides. So 2x minus 1 is equal to 7 to the power of 2, which is 49. So now 2x is equal to 49 plus 1, which is 50. So this will be 50 over 2, which is 25. Now let's work with one extraneous roots, which mean we will solve this equation for the unknown n, and when we find n, we will plug it again in this equation and see if we will get minus 7. If we get minus 7, that answer is acceptable. If we get a number different than minus 7, that means our solution is not allowed to take. So n minus square root of 5 minus n is equal to minus 7. So we will add plus 7 to both sides, which will give us n minus square root of 5, n minus square root of 5 minus n plus 7 is equal to 0. And we will add plus square root of 5 minus n plus square root of 5 minus n. We will get n minus square root of 5 minus n plus square root of 5 minus n plus 7 is equal to 0 plus square root of 5 minus n. And this will cancel out, and we will end up with n plus 7 is equal to square root of 5 minus n. Now to get rid of this square root, we need to take the power of 2 to everything. N plus 7 square is equal to 5 minus n, which means which means that n squared plus 14n plus 49 is equal to 5 minus n, and this will give me n squared plus 15n plus 44 is equal to 0. Now we have a quadratic equation which we will solve by using our method that we saw in the previous video, which says that we need to find two numbers that if we multiply them we get plus 44, and if we add them we will get plus 15. So two numbers that if you multiply them, something times something, it will give me 44, and this thing, same thing, plus the same thing, it will give me 15. So I think this is easy. It's just 11 and 4. So 11 times 4 is 44, 11 plus 4 is 15. So we can directly go ahead and write our equation, this equation as this, as n plus 11 times n plus 4 is equal to 0. So the roots, the solution here is n is equal to minus 11 or n is equal to minus 4. So we have two solutions that we need to plug in our equation and see if it's working or no. So to do that, let us take, so when n is equal to minus 4, my equation, this equation, I'm talking about this equation, will be minus 4 minus square root of 5 minus 4 is equal to what? Minus 4 minus square root of 9, which is minus 4 minus 3, which is minus 7, and this is good. It is equal to our equation here, exactly what we have here. Now let us try with n is equal to minus 11. So my equation will be minus 11 minus square root of 5 minus 11, which will give me minus 11 minus square root of 16, which is minus 11 minus 4, which is minus 15. This answer is different than minus 7. So we can say this is the solution, and the value of n is equal to minus 11 is one extraneous solution, and the extraneous roots occur because squaring both sides and solving the quadratic equation may result in roots that do not satisfy the original equation.